It's my pleasure to introduce to you Dirk McClure. He is a graduate of Kansas State University's College of Architecture, Planning, and Design. He practiced sports architecture for 8 years. He joined the precast concrete industry 16 years ago. He is currently the Director of Business Development for the Enterprise Precast Concrete Company, where he's responsible for 5 state territories: Kansas, Missouri, Illinois, Oklahoma, and Arkansas. Dirk is also currently the chairman of a committee, the Altus Group, an innovative consortium made up of a variety of different precast concrete producers and vendors. They collaborate, pool resources, doing research and development to make precast concrete better. Also, what I would like to share with you is that eventually the members of the Altus Group will compete against each other for jobs. And that's an impressive consortium when you consider that. Also, I'd like to welcome Lena Weckstom, who is an architect from Finland. She studied urban design and architecture at Aalto University in Helsinki and at the Royal Danish Academy of Fine Arts in Copenhagen. Lena worked as an architect in both Helsinki and in Madrid before her work began in graphic concrete in 2012. She's currently the leader of in graphic concrete in an innovative company focused on aesthetics of architectural precast. She's advised and worked on many precast projects in various countries and with a variety of different design goals as it relates to graphic concrete. So at this point, I would like to turn the program over to Dirk McClure, and thank you for participating.
Well, thank you, Terry, for that introduction. You hearing me okay? Making the new practice of registered with AIA Kansas. It is good for a learning unit that I do believe also qualifies towards health, safety, and welfare requirements. I'm not real big on talking about what I'm getting ready to talk about, but those lawyers in the Washington AIA start the hour by talking about some advantages of precast concrete related to the COVID-19 pandemic and the job site concerns that we've seen as a result of that. We will talk about, it's not often we get to talk about what's new in the industry. We'll talk about PCI's new and improved architectural program that's going to take effect next year. Lena from Finland concrete. This is a technology that has existed in the United States for about 5 years, but they've been doing this overseas for 15. And then we'll cap the hour by looking at a real world example of this project with the application of a case study for the Murphysboro Performing Art Center in Murphysboro, Illinois. What a year it has been. And that might be the understatement of the year. I sincerely hope all of you are staying healthy. I hope you're staying safe. And that goes for yourselves, your families, as well as your work families and communities that you work with. As a result of the pandemic, we've seen a lot of new requests and a lot of new concerns about the way that job sites operate. People want to take as many precautions as they can. One large emphasis is minimizing the number of people they have on job sites, spreading out as much as possible. One inherent advantage of a precast concrete solution is that you are producing this entirely off-site. So if it's an insulated sandwich panel, you're producing 100% of your building envelope off-site. It's in a controlled environment, so these precasters are taking precautions. They're spreading out, they're sanitizing, they're taking temperatures every day. They're doing everything they can to keep their employees safe and healthy. And where that really becomes a tangible advantage to the overall team is when those pieces start showing up at the job site, because you have fewer deliveries to the job site, and you have fewer people on the job site. A crew of about half a dozen people, a crane operator, an iron worker, and a handful of foremen can put up an entire building facade. So there's definitely some interest in that. We're seeing on projects that are considering which way they want to go in terms of building facade, building design, building material. There is another strategy is to get on and off the job sites as quickly as possible. And with precast, you're putting about 8 to 14 panels up a day. So these do go up remarkably fast. And another thing that is another advantage that's probably important now more than ever is all-weather construction. One of the challenges we've seen in the precast world is schedules moving around quite a bit. There is either uncertainty of the job, or it might just some things happen with other trades, and their schedules are shifting a lot, construction schedules. So with precast, as long as you've got the footings and the foundations down, the precast panels can go up in any weather. And that's a real benefit, because if had it been, some other materials, there are a lot of other building facades that it basically stops in the winter and you have to wait, until things warm up a little bit. With precast, that's not the case. So that's enough about COVID. Let's talk about aesthetics. There are 4 primary finishes for precast concrete. And what you're seeing here are 2 different mixed designs. The gray is one mixed design, the red is another mixed design, each of them split up with reveals showing the 4 different primary finishes. One is polished, which is the higher end, more expensive finish. It's a mechanical process. It leads to a smooth, shining, reflective surface similar to granite. It's very common on floors, not as common on vertical surfaces, but certainly can be done. Then you have exposed aggregate. Now, while we don't see this as often on entire building facades, you often see it on reveals or maybe the base of your building. It's used a lot with other precast finishes. That for the rough rock look, basically a chemical retarder is painted at the bottom of the bed. The panel is shifted up on site. It is cleaned, and that retarder at the bottom of the bed keeps that surface from curing. So that surface area of concrete washes off and it exposes the rough rock. The most common finish in the industry is a sandblast finish, and that is basically where they mar the aggregate. It generally results in a rougher finish, and there's varying degrees of sandblast, light, medium, and heavy, each yielding a slightly different appearance. And then there's acid etch finishing, which is a liquid-based application that just starts to take off the form finish, and it's a very kind of clean, sparkling, almost a sugar cube appearance for the project. And one strategy for saving cost is to keep the same mixed design on the panels. And you can use multiple mixed designs on a panel. We're going to talk about that a little bit later. But if you use the same mixed design, you can get this many looks on a panel, or a combination, maybe 2 of them, 3 of them, whatever, by just separating with reveals rather than putting multiple finishes in the same panel. That's a strategy that a lot of designers that know their precast do when they have clients with champagne taste, but they only have beer money. So something new in the industry, is the new certification system that's going to take effect next year. PCI, you could think of it as the AIA of the precast industry. It's the Precast Pre-Stressed Concrete Institute. It is the largest, most stringent, and most widely accepted precast certification agency in the business. They've got a proven history. They've been around over 50 years. They have nationally accepted standards. To belong to this, producers agree to 2 unannounced audits per year. So they don't know when the independent inspectors are coming. They just show up and they check reinforcing, they check curing strength, they check quality, safety, finish capabilities. So producers really have to maintain a lot of standards to be able to meet these quality control requirements. So it really makes the industry better. Having a pre-qualified bidder gives you a higher probability of success on your projects. You know your producer's going to be able to meet a certain level of finish expectation, and ultimately it's going to save time and money because there's less probability of something going wrong with a pre-qualified bidder. So question might be, why change? Why the new standards? This is really all about PCI raising the bar. There is a standard that did not exist before that some producers are going to qualify for, the top tier standards. So there's been some technology advancements that have allowed for these. The industry has been calling for, tighter joints, like 1/8 of an inch joints for a long time. We're finally, at a place where we can do that. So it gives you more options. It allows you to align producers based on their specific capabilities, to identify producers with advanced complexity. And in putting this together, it wasn't just precasters. We got feedback from architects and contractors that work with precast a lot, and they had a lot of opinions that were considered and put into action. And this new system is going to take effect July 1st. So what that looks like is everything that bids before July 1st of 2021 will be the old PCI certification system that many of you are familiar with. Everything after July 1st of 2021 will be the new system. So let's unpack that a bit. The current system, you have a couple of large catch-all categories, and many of you are going to be familiar with this. A1 is the architectural certification. Then that's the 117 manual. They're tighter tolerances. To do this, producers have to be able to acid etch and do a certain level of finish. So these are your cladding jobs, your higher end load bearing projects. Then you have what's called CA, which is the structural projects. These are typically your parking garages, your warehouses, your more utilitarian projects, and they have bigger tolerances, less of a finish criteria. The gray area was if you had a school, for instance, that had pretty high finishes on it, where should it go? And a lot of architects would put that into A1 because they wanted those tighter tolerances and they wanted those higher finish capabilities. Some would just consider it purely a structural job and they'd put it in CA. But the new categories are a little more spread out and there's really a place for everything. That's one advantage. And then architectural trim units, those are your sills, your headers, your monument signs, your smaller pieces, your medallions. So with the new categories, you have the highest level is what's called AA, and then there's AB. These are two levels that did not exist before. So there were some buildings that were built to this level, but there was never that never existed as a minimum standard that a producer could aspire to. So AA is going to be, that's going to be your cathedrals. Those are going to be your performing arts centers. AB is going to be your upscale, very upscale buildings, your highest level schools. A lot of the school and this was a tolerance level that didn't exist before. AC is going to be a lot of, most of your schools are going to go in AC, I would say. AD, you're getting into warehouses, more utilitarian big box stores and things like that. And then the trim category has remained relatively similar, but there's some higher standards that they aspire to in terms of doing mock-ups. So let's kind of just unpack what that might start to look like. Your AD category, you're going to have, again, the more utilitarian jobs, the warehouses and that sort of thing. This is going to be gray concrete. Most of these projects are going to be painted. Then there you step up to AC, and that's what CA used to be. Then you step up to AC. AC is what A1 used to be, the architectural standard. So you've got more definition. Then you've got category AB, which is you can see the bump outs, the changes in transition, the cornices, the additional complexity. And then you get to AA, those tolerances tighten up. And those are the really ornate projects. So to understand it a little better, it's good to see what each producer that is aspiring for each category is going to have to be able to produce. For AD, for an exposed precast panel, they need to be able to do a flat panel with reveals. For AC, they need to be able to do the same thing, a flat panel with reveals, but the reveals are a little more complicated and they need to be able to turn that corner. With AB, you've got to be able to do 2 mixed designs within the same panel. You need to be able to do at least 2 finishes within the same panel. You have to be able to do curve panels. You start to introduce bull noses and projections. And then with AA, it is similar to all of those things, but they introduce an increased level of detail. So another mock-up, similar concept for a thin brick project. AD producers just need to be able to do a flat panel. AC producers need to be able to turn the corner with those panels. AB producers need to be able to produce an L or a U-shaped piece. They need to be able to create a transition between the brick and the other exposed precast finish and make that transition successfully. And then with AA, you see they start to have more projections, more cornices, more detail. The other mock-up that and not every producer is going to be AA. There are some producers that are going to say, you know what, we're a structural producer, we're going to stick in our lane and we're going to do AD and AC jobs because that's what we're good at. You know, and the other producers are going to aspire for these other categories, and that's helpful because for a certain caliber of job and complexity, you want to have a certain caliber of producer, and that's one of the benefits of what this provides. So with AD, again, with a form liner, same thing, flat panels. With AC, flat panels with a return, and with AB and AA, you can see the additional levels of ornate complexity. And then with AT, that categories remain fairly similar, but they have introduced a mock-up process where they need to be able to show that they can do curves, you know, in certain levels of complexity for a small projects division. So let's see what this looks like with some job examples. And as you're looking at these, hopefully you can maybe kind of start to think about where your job might fit into this. With the trim category, you have single color components, single pour returns. You can do radiuses. There'll be while there's no site survey, they do need to match 117, which is the old A1 architectural standards. So here's an example of an AT project, this medallion for Creighton Preparatory School. This was a little one-off medallion done for a private school, and you can see the amount of detail that you can get into with a 3D form liner. With another AT project, and this was actually done with graphic concrete. Lena's going to unpack that in detail in a moment. A really great thing about this project was for this private Catholic school, the art teacher actually designed this cross medallion. So you had an unprecedented amount of owner involvement. And one little plug I'll put in for graphic concrete, I know we see in some cities and municipalities, there's a requirement for 1% art, permanent art. That fits perfectly in with graphic concrete if you commission a artist, or a local liaison to do that design. So that's AT. Getting into the buildings, AC and AD categories, here you're looking at single color panels with the cement AC see, you're going to see white on most projects, gray if it's allowed. AD is going to be only gray. Most of these buildings are gutted thin brick, but really not anything else. So no inset stone or anything like that. You're going to see single pour returns. There's not going to be any curved or radius panels. The quality control level is 1 or 2. And while there's not going to be an architect or contractor survey or site evaluation, there is still a plant certification process that is measured that's going to be in effect. So with the AC jobs, they need to meet the old A1 tolerances of 117. For the AD projects, they need to meet the old CA tolerances of 116. And for AC, a PCI certified erector is required. Here's some AD project examples. You hearing me okay, Lena? Give me a thumbs up if you can. So the Middlesex warehouse, here you can see on a more utilitarian, I know there's a delay, how about that? So on the warehouse, you can more interesting aesthetically. There's a little fin here in the entrance area, and they've done some things with reveals to give it a repetitive, geographic, kind of a concept and flow and repetition. Same with this adventure aquarium. This was painted different colors, and then they applied some metal panels to the facade to give it a little more flair, a little bit more of a whimsical, appearance. So these are going to be your kind of your warehouses and your big box store kind of projects. A1 standard. So you can do a pretty nice AC job. This school in Grand Island had 2 colors of thin brick. It has this overhang that flares out. That's actually 2 different finishes on the same panel. So you've got a combination of acid etch and exposed aggregate in the same panel. We talked about that a little bit before. For this project in DC West, there is a thin brick, a combination of thin brick and exposed precast, and they spread out the brick in a way that it has kind of this speckled appearance. The design concept was that it was supposed to actually emulate crashing waves on a beach, but a pretty cool little design in this project in Nebraska. Stepping up to AA and AB categories, these are categories of quality that did not exist before. Here you're using multiple colors within a single panel. You can use white or gray, but most of these projects are going to use white. There is an embedded, you can do, in addition to brick, you can do embedded stone, tile, terracotta. We're going to show an AB example later that used graphic concrete. You can do cold joints and returns, 3D formed surfaces, so you can do L-shaped pieces. The quality control level steps up to level 3. And here's a couple of layers of accountability that didn't exist before. With AB, you're going to have a project survey with the architect and the contractor. And then for AA, you're actually going to have a PCI site visit audit, on the project. So they'll not only audit the project in the plant, but they'll audit it on site. For those projects that just have to have a lot of detail and they have to be absolutely perfect. So AB has tolerances similar to the previous A1, 117. AA has tolerances that are actually tighter than what existed before. PCI certified erectors are required, and it is also required that the precast producer have in-house BIM capabilities. So when you get to an AB job, here's the Kiewit headquarters in Lenexa, Kansas. This was originally designed as a software company by Clover Architects. When Kiewit moved in, HOK did the renovation. You can see a lot of detail here in the reveals, in the projections, things happening in different layers and planes. It's a combination of thin brick and exposed precast. And one of the things, it switched from masonry to precast for schedule and economic reasons. But one of the things they did is they figured out they were able to there was a lot of repetition, and these panels did go up very, very quickly. Another example of an AB project is the Capitol Federal Hall project in Lawrence, Kansas. Gensler Walker was the local architect on that, with Gassinger Walker with Gensler out of Chicago. These panels came up to an apex, and the way the light hits them in different times of the day, that they never look exactly the same depending on what time of the day it is. So let's talk about the AA jobs. The University of Nebraska College of Business was a project where limestone was set into precast. So if you look at these windows, you can see the amount of detail, and this is a tighter level of joints and tolerances that previously existed as a standard. Here, this gives you a peak. One is in different planes, but at the end of the day, they're set into precast and it installs as a flat panel. There's also, even though there's a lot of detail, there's a lot of repetition on this project, which gave it some economy. And the other AA example I have is the Advanced Learning Library in Wichita, Kansas. This was 3 different mix designs, 3 different finishes. You had exposed aggregate, acid etch, and sandblast. Here you had a form liner with geographic patterns to give it to some different shadowing effects in the day. Here you had a more undulating wave pattern on this facade. So that just kind of gives you an idea of what you can start to see with AB and AA. And this little catch-all shows you where these categories fit. You can have one mixed design with AA and AB, or more than one mixed design with AA and AB, just one with the other categories. The AAs can have stone and terracotta and tile. With the others, it's thin brick. All can do flat panels. And then there's different levels of what you can do with 3D forms, returns, that sort of thing. And I'm on my time here, so I'm going to go ahead and hand it over to Lena in just a moment. I will just show you. You're probably thinking, wow, that's a lot of information. How can I digest that? I'll show this website again at the end of the hour, but I'd encourage you to take a note of it. If you go to pci.org, architectural certification, it'll give you more information on that program, and you can see about where your projects might fit, whether it's an AA, AB, AC, or AD project. And with that, I will turn things over to my co-presenter in Finland, Lena.
Thank you very much, Dirk. I will start sharing my screen. Let's see if it works. Let's see. Do you see it now? Is it okay? Okay. Well, hello, nice to meet you all, and I was going to say good evening because it's evening here in Finland, but good day to you everybody there, and very nice to be here talking to you. I'm going to talk about graphic concrete, or graphically imaged concrete as it's called. This is an invention that dates back to the late 1990s. It's an innovation from Finland. And this guy here on the photo, he was playing around with surface retarders and tried to figure out how you could pattern concrete in an easy way. So he came up with this new technology, and then there was a lot of research and development, but today we have many projects all over the globe. We have been working with many precasters, but as Dirk said before, North America is quite a new market for this invention or this technology. But the Altus Group precasters, they are all able to use this technology, so that is very nice. Dirk already talked about this. I think you need to understand a little bit about concrete in order to understand graphic concrete. When you mix aggregate, cement, and water, that's like the basic concrete mix. Cement and water makes up the glue that would, when it hardens, it glues the aggregates together, making the concrete. Here you can see the normal concrete finishes, the smooth form finish. That's when you have the cement glue. When concrete hardens, the cement glue rises up to the surface, covering the aggregates that would be inside the panel. So that's the normal gray, smooth, or white, smooth concrete. Then, as Dirk said, if you take away this little layer of cement from the surface, you would expose the aggregates, and then you have the exposed aggregate finish. The graphically imaged concrete or graphic concrete, that's a combination of these two. So it's part smooth and partly exposed. I'm going to explain how this is happening. But first, it's good to remember that this is a technology for the precast industry. It can allow you to transfer anything. You can print on a printer, you can transfer to your concrete surface. But it's important that it's precast. It's not working for on-site casting, as you can see when I'm explaining this technology. Here is how it works. The designer, maybe you are like, oh, okay, I'm gonna design a school. So what would be nice to put on the facade of a school? Well, I gotta put in some texts and something about, with learning, and you design a pattern, whatever you would like to see on your facade. This pattern would then be printing on this big roll of, we call it a membrane. It's like a special paper. We would print the pattern on that membrane in Finland. And then this membrane would be shipped to the local precaster in the United States, who would be the one who would actually then make the panels. So paper or membrane made in Finland, panels made locally. It would be stupid to ship the stones. So it's very important that it's local production. So the membrane arrives at the factory. They would cut out the piece that is needed for the panel, lay it down in the form, and cast concrete on top of this membrane. This print you can see here, it's a surface retarder. So that print would hinder the cement on the surface from hardening. Even though the panel is cured, those parts that has been touching this ink would still be soft. So the concrete has cured, it's extracted from the form, and here you can see they remove the membrane, and you can see where the text is kind of white in the photography, that's where the surface is still soft. So then at the factory, they just go over it with a pressure washer, just pure water, and you wash away the surface cement only where this special ink has been. And that way you reveal the pattern, you have your graphically imaged concrete ready, and the panel is ready for installation as such. And there you have your beautiful graphic concrete school. The membrane itself, it's very large. It's the width of the print is 10.5 foot. And then it's as long as what you would need for your project. This membrane is disposable. It's used once. So at the factory, they take the piece they need, they lay it down in the form, and then they dispose of this membrane. So it's super flexible. You can have different sized panels, different forms. You can have small pavers. Then you just cut up the membrane to the pieces you need. If you have a really, really big panel, these membranes can be joined. So there's actually no limit to the size of the panel you can do with these membranes. The good thing is that this is totally environmentally friendly. It's recyclable. After use, you have to take away the cement residues, but otherwise you can burn it, you can recycle it. It's basically paper. It's very good for the working conditions in the factory because it doesn't emit any harmful substances or gases, dust, nothing. If you compare with liquid retarder, you can have the solvent-based retarders, so you can do maybe a pattern with sandblasting and a stencil, but also with the sandblasting, you could have the dust inconvenience. So when using this membrane, you can have very good working conditions at the factory. So I think that's also an important aspect of this technology. The production itself at the factory doesn't really require any special equipment. If the factory can make exposed aggregate surface, they can also make the graphic concrete surface. It can be used with very different mix designs, very different types of concrete. It can be the heavy traditional concrete. It could be the concrete you need to compact, or the self-compacting concrete. If you want to make an interior design, you can use it for glass fiber reinforced thin concrete boards, or if you want to make a flooring, you need ultra high performance concrete, super hard concrete. You can use that with that also. Important to remember, it needs to be precast and horizontally precast on a table. As for the structural aspects, This exposure is very fine because you're only washing away the very surface of the panel. So you don't need to think about any structural, changes when you're using this method. If you use a form liner, you need to have more concrete because you have those curved forms, so you need to add some concrete in order to carve some away. But with this technology, you use as little concrete as possible, and the panels always they stay very slim and light, and that's of course that's very positive when it comes to transportation and installation. Another very nice thing is that since this is 100% concrete, it's very durable. It's virtually maintenance free, and since this is a flat surface, it's not going to attract any dust. The rain will wash off the dirt, and if you need to clean it, it's just you can power wash it. It's as durable as the concrete itself. Then the design possibilities. As I said, whatever you would like, you could have on your concrete. And then you can vary the looks by choosing different aggregate colors, or you can have different colored cements. You can have gray cement, white cement, or you can add pigments to the cement. Of course, you cannot color the stones, but with pigments, you could color the smooth, fair-faced surfaces of your design. Then, of course, you can also paint this or stain this. We have a project, like interior project, where they painted it all in gold, still having this structure. Of course, you could do that, but then you lose the maintenance-free aspect. So, if you paint, of course, you need to repaint after some years. Here are some examples. If you have an image like this, it's like a photographical image, you can rasterize it in Photoshop. When you do graphic concrete, you have to think like exposed or not. There's nothing in between. So to have the gray shades, you need to, how dense are your dots? And how large are your dots? How much of the black stone is exposed? That would give you all these gray tones. So here you see the close-up. That's what it would look like when you go close to this wall. It's super tactile. I actually seen people like fondling the wall. I think that's lovely, to see how nice and tactile this surface is. And then when you move away, the image appears. So it's very interesting on different level. It would give you more when you move in the environment. And I think that's a very nice thing. About coming close up to the wall, the raster, whatever Photoshop can do, you can have like here, just stripe, a little bit more romantic, a little bit more soft. This is a very nice project. It's in Italy. It's a chapel, and those panels that you see there, those round lights, they are actually holes or small windows in the panel. So at a certain time of day, the sun rays just come in and fills up this room with beams of light. It's so beautiful. So if you ever go to Bergamo in Italy, make sure to call me and I will tell you where this is. This is very nice. This is super romantic. This is Italians, but in Finland, we are like, this is the romance level in Finland. We do stripes and a lot of stripes. But this is nice, I think, to show that it doesn't have to be so much or like a photography. Even a very simple design can be very nice. And here you can see the crisp corners. There's not like the forms if you do with a form liner. There's nothing that can chip. The panels stay slim and light. You can get the color from the aggregate, as I said. Here's a project with red aggregate. This is very popular in Finland. We have a lot of red granite. Then you can get the color if you add pigments, like here. You have to remember that the pigments would add costs, of course, to your project. Blue pigment, I think, is the most expensive, at least here in Europe. And it's also the pigment, I think, that fades the most. So you have to think when you use blue pigments. But in this case, this is one piece of art. So even if it fades a little bit, it doesn't matter. It's not like you can compare it with the next panel. So in this case, this is, I think, really beautiful. And you can see all these tones of gray or the light grayish blue, depending on how much you expose of the black stone. Here's an example of a painted building. this just looks green from afar. You can't see anything, but when you come close to the building, you can see this little etching because of, every little aggregate, every little stone would make a little shadow. So I think that gives it a very nice surface to an otherwise just painted concrete building. The contrast can be very discreet, white aggregate, white cement. You don't make a fuss, you just have it a very elegant solution. Sometimes you need very high contrast. Highest contrast is with the black aggregate and white cement. This is a project in the United States. I think it's actually finished already. In this case, you need to see it also from afar. Otherwise, your money is lost. I mean, you would make this with white aggregate and white cement. Nobody can see it. So you really have to think about your viewing distance and what you want to show when you start designing your graphically imaged concrete. Curved forms, you can do that. Whatever the membrane would kind of bend to that shape, you could do. If you have a very complicated form, bending here and there, that would not work with this technology because, of course, the membrane cannot turn so many ways. But something like this, you can easily make with the membrane. Then you can make 3D effects, which I think is super cool. This is the same background I have here because I love this building. It's a book archive in Denmark, and they made this whole thing look like a bookshelf. It's actually like a piece of art because it stands alone on a hill, just like you can see it from wherever you approach. And I remember the architect told me that he got this project and how boring to make like a warehouse. They were thinking about not even accepting this as a job. But then he said, it was the most exciting and, job that he had done. And he's really eager about this. So I like this one. But again, it's totally flat. When you look at the small image here to the right, you can see that it's all just made up gray tones that would have your brain think that it's 3D, but it's not. Here you can also see the nice thing about precast, that if you have a full concrete facade, no paint, you don't need to have the roof coming over the wall to, to kind of protect the facade from rain or dirt. You can go with this very, very nice, cool little detail, which I like in this case, especially because it makes this like the coolest box. There are ready-made pattern designs. If you don't have time to design your own, there's a lot. You can find it in the web. They're easy to use patterns. They're proven to work. You can also just use them as inspiration. Most of the patterns are kind of wallpaper type repeating patterns. But you can modify them if you want. You can scale them, or you could add on things to them. That wouldn't change the cost of the membrane. As long as your design would be like a repeating wallpaper type design, it would cost the same as the stock designs. Because we don't think, if you are like, you are inspired and you want to make something nice, we're not going to raise the price for that, because manufacturing this, making this membrane, it's no difference for us if it's your or ours design. As Dirk said, sometimes you need a BIM model for your project. Well, there's also JPEG images available, or these standard patterns, so you can check them, put them into your renderings if you like. But if you don't want to take a pattern that would be a standard pattern, you could, as I said, do anything. Here are some examples. You can have a flower or a stripe, a text. You can imitate plaster or brick. Here you see on the left, that would be the print proof for the brick. We work with on-off, as I said, exposed or not. So in the original file that you would send us, you would have the black. That's where we have the ink. That's where you expose the aggregate. And where you have white, that would be the smooth surface. So at this brick, I always say that they made kind of a boring traditional brick, but for the same price, you could do the coolest designer bricks. So I think that's a very nice aspect to this, that it doesn't really matter what your design is. Of course, if you want to make something really, really big, one piece of art, a huge panel, that's going to affect the cost. You saw our membrane is 10.5 foot wide. So if your panel would be 10.5 foot wide, and as tall as possible, or whatever you would like, that's the most cost-effective solution, because we sell the membrane per linear foot. So of course, if you can use all the membrane, that will be cost-effective. Also, with this membrane, it's like with any printed material, that the more you repeat, the cheaper per square foot it will be. It's like making one business card or 500 business cards. You know, the price difference of one is going to be really much, because the setup cost is high, but when we start printing, you know, it's getting cost effective. So also larger projects, more cost effective. In the United States, we have been comparing prices, and it's, we can say it's more or less, if you would have a repeating kind of wallpaper type design, you can compare this finish to like a brick clad precast, more or less. So, and I would say that's not anything very special. I have seen that you do that a lot. So I think this was my last slide now. Yes, now I think Dirk is going to take over again and tell us a little bit about an example that you made with graphic concrete.
Yeah. Thanks, Lena. So
Thanks.
it is not advancing. Let me try this again here. Screen. There we go. All right. The example is the Murphysboro project in Illinois that we showed earlier. Now, this would be, and we talked about these categories earlier, this would actually be an AB category. This is a building that it didn't have a lot of right angles. You know, so it had, from an architectural and a constructability perspective, it had some challenges going on. It was at the time the not the first, but the largest and most notable graphic concrete project in the United States. Here you can see where how it started on the drawing board. They had this birch tree pattern that they wanted to use. The next step, they got a precaster on board, and they went to mock-up. The nice thing about mock-ups are you can start to see that pattern take form, and then you can give some feedback in terms of, you know, what you want to do with your reveals, the depth of your reveals, the number of your reveals, the placement, that sort of thing. Then this was the first panel that we poured out in the yard, cleaned it, and just waiting to go out to the job site there. And this is the building itself. Interesting history on this building as a side note. This was a fast track project because it was replacing a previous smaller performing art center that actually had a catastrophic failure. It collapsed. Fortunately, it happened, you know, when it was unoccupied, so nobody got hurt, but it was an older CMU facility with a timber roof. So as you can imagine, there was a lot of sensitivity about, you know, what are we going to build it with this time? Let's pick something durable. Let's pick something that's going to last. Precast was chosen as a material, and they also, as visible as this project was, they wanted to do something with some wow factor, you know, for lack of a better descriptor, and graphic concrete certainly fit the bill for that. You can see that pattern here. Here's kind of what it looks like on the ground level. Looking up, there's they actually have LED uplights. I wish I had a picture of it at night, but they splash it with different colors at night. It's going to be really interesting when these trees grow up, you know, to kind of just see kind of how that looks with the birch wooded theme. Here, I like this because this shows you what you can see when you walk up to the panel, and then when you back up, that image starts to take form. And I saw Dan asked a question about, we're going to get into questions here in a minute, but he asked a question about graffiti sealers. I'll just tell you, from a durability standpoint, I mean, you can walk up, you can touch it. There's areas in Europe where they put this down on the floor and it's actually taking traffic. So it is that kind of durability. People, will, if it is street level, they will, you know, walk up and run their hands across it and everything, and it's fine. If it is an area where you're concerned about graffiti, you can put a graffiti sealer on it. You know, it's fine without a sealer, any sealer whatsoever, if that's not a concern. Here it's a little bit off the eye level, so these panels were not sealed. And here you can see the inside of the gym. You can see those joints between the panels. They actually dressed up this gym a little bit with a lick and stick stone just to dress it up a little bit. And as you come over the bridge here, you kind of see in this wooded area the building kind of out on its own. And that completes the program portion of our seminar. What I might do is just before we jump into questions, I might just remind you there's some websites on here, a little call to action. The one at the bottom is the one I showed earlier. If you're interested in more information about the architectural certification program, Altus Precast is where you can find all the information that you're looking for about graphic concrete. So that's just a couple clicks away to get to Lena and all the information about graphic concrete. If you want to reach out to me personally, you can reach me at Enterprise Precast. And I want to commend everybody for doing something different. This year has been very different. We've certainly enjoyed presenting, and I hope we got through talking before you got through listening. Let's see here, and I will go to the chat here.
Yeah, Dirk, we've got 2 questions. Do you want me to read them to you?
Yeah, I'm going to stop sharing my screen.
Okay. The first one, is there a method or treatment to protect the image from graffiti, or what is the cleanability of the image?
Yeah, I took kind of a preemptive shot at answering that. Lena, do you want to take that one?
Yes, I mean, you have to treat graphic concrete as any concrete. So whatever products you have that would work with concrete, you know, the traditional graffiti cleaners that you have over there would work. The only thing is, I would say that you need to kind of test them, because they might give a little bit of shine to your concrete, and that might change the color. They might not be colored, but they might have a shine. We have seen that problem here in Europe, that you might treat just the lower part of the facade, but then, you know, the sun comes on the facade and it looks lighter. So you have to really test if you're just going to treat one part of your facade. But the thing that we also have been noticing is that these graphic concrete panels, they are left alone because maybe these artists think that there was already an artist involved and they don't want to, you know, spray on this. So we have, I should have that picture somewhere, but I don't have it here, but it's a huge graphic concrete facade. And then you have the kind of metal doors to wherever there would be like technique, like, you know, some plumbing or something behind those doors. And those are full with graffiti, but the graphic concrete is left alone. So I think that's a nice thing to notice.
Okay, and then this question is also for Lena. Are there any cost differences for heavier patterns? Patterns having more of the retardant ink versus more blank paper area?
Oh, that's a good question. The pricing of the membrane, it doesn't matter if it's a dot or a stripe or a dog. How much of the ink is used, it does not matter. It's more about, as I said, the size of your image and how many times it's repeated. That's mostly what matters. And then it's good to remember that when we talk about price, it's only the membrane. That's like having, like, you buy a jar of paint, but after that you need a wall and you need somebody to paint the wall. So it's really important that your local precaster would give you the final price for final panel with the pattern on it. So the pricing really, it's something that we would do with the precaster. They would ask us, how much would this design cost? Of course, we can help the designers and indicate, like, you know, you want to go expensive or you want to like do something cost effective. But it's good to remember that the final price always comes from the precaster, because it depends on so many things. You know, how big is the panel, how thick it is, it's a sandwich panel, you know. So that's good to remember.
Yeah, and I might just add, if you're doing a project, for instance, like Murphysboro, that had a lot of repetition, you know, so there's, you know, you get past the setup, and that those are the kind of projects where you're, you know, very easily going to get within striking distance of the cost of a thin brick project, probably just $1 or $2 per square foot. You know, if it's just one facade and you're doing like a person's face and it's just one thing in one place, you know, there's a, you know, some setup fee, and, you know, that one's going to get a little more expensive. But I mean, with just like with anything with precast, with form liners or anything else, repetition makes it, is where you really hit your stride in terms of efficiency.
And that is all we have for questions.
Okay,